Welcome to the Explainer. Today we're taking a completely fascinating look at the invisible architecture of the internet. Have you ever wondered what exactly makes everything from loading a simple web page to playing intense online multiplayer games possible? Well, it all comes down to a set of rules working tirelessly behind the scenes, specifically within something called the TCP/IP model. In this Explainer, we are going to unpack the transport layer of that model, cutting right through the heavy jargon so we can see exactly how our data travels across the globe. Okay, let's dive right into this. Here is our roadmap for today. First up, the internet's mailroom. Second, TCP, the reliable courier. Third, UDP, the speed demon. Fourth, ports, finding the right door. And finally, some real-world applications. Section 1, the internet's mailroom. So think about this for a second. We all experience those really annoying daily internet frustrations, right? Maybe a bit of lag during a match or a web page that just loads totally broken. But when the data actually does arrive at your computer or your smartphone, how on earth does it know whether it's supposed to go to your web browser, your email app, or your Spotify player? I mean, it's just data. This right here is the fundamental problem the transport layer solves. To answer that question, we've got to look at the transport layer itself. In the standard 4-layer TCP/IP model, this layer sits right smack in the middle, just below the application layer and right above the internet layer. Its whole entire job? Managing what we call end-to-end communication. It doesn't just get the data to your computer, it makes absolutely sure that data is handed off to the exact right application and in the right condition. You know, you can intuitively think of the IP, the Internet Protocol, as the delivery truck. It uses your IP address to navigate the wild roads of the Internet and basically drops a package at the front door of your apartment building, which is your device. But here's the catch. The IP has no clue who lives in which apartment. The transport layer? Well, that's the internal mailroom of your building. It looks at the package and goes, yep, this goes to application number 80, and it delivers it right to that specific door. Pretty cool, right? So let's meet the most famous protocol working inside this mailroom. Section 2, TCP, the reliable courier. All right, so TCP stands for Transmission Control Protocol. And what's really interesting here is just how fiercely protective TCP is of your data. It's what we call highly reliable and connection-oriented. Well, what does that actually mean for us? Well, it means TCP ensures every single piece of data arrives flawlessly. It orders the packets so they don't get all jumbled up. It performs error checking. And get this, if a piece of data gets lost along the way, TCP automatically retransmits it. It is literally the registered mail courier of the internet. Now, when your application hands a massive file over to TCP, TCP doesn't just shove it through all at once. Nope. It chops that data up into smaller, much more manageable pieces. And in the transport layer, when we're specifically using TCP, we call these little pieces of data segments. But here's the kicker. Before TCP sends even a single segment of your data, it absolutely insists on formally introducing itself to the receiving computer. It does this through a very strict process called the three-way handshake. It goes like this. Step 1, the client requests a connection with a SYN, or synchronization packet. Step 2, the server acknowledges that and replies with a SYN-ACK. And step 3, the client confirms with a final ACK. 1, 2, 3, handshake done. Only after this whole polite exchange is complete does the actual data begin to flow. It's safe, it's secure, and delivery is basically guaranteed. But what if you simply don't have the time for polite handshakes and guarantees? That brings us to Section 3, UDP, the speed demon. Enter UDP, which stands for User Datagram Protocol. If TCP is the careful, meticulous courier, UDP is the completely reckless speed demon. It is connectionless. That means it skips that polite three-way handshake entirely, just ignores it. Because of this, it is incredibly fast with super low latency. However, there's a catch. It offers absolutely no guaranteed sequencing, and it never, ever retransmits lost data. If a packet gets lost in transit, UDP just shrugs and keeps moving. And just like TCP chops data into segments, UDP also breaks data down into smaller chunks. But to tell them apart, the data units that are produced and used by UDP have their own special name. We call them datagrams. Let's put them side by side to really lock this in. TCP is your registered mail. The courier knocks, waits for you to sign, hands you the package, and makes absolutely sure you got it perfectly intact. UDP, on the other hand, is like a paperboy on a bicycle. He just chucks the newspaper at your porch while riding past at top speed. If it lands in the bushes, he doesn't stop. He doesn't care. He's already delivering the next one. So we've got the mailroom, and we have our two very different delivery protocols. But how do they actually label the packages to find the correct application? Section 4. Ports. Finding the right door. 65,535. That is a massive number, right? And it represents the absolute maximum amount of 16-bit ports available in the transport layer. These ports act exactly like those apartment numbers we were talking about earlier. When data arrives at your device, the port number tells the transport layer exactly which software application should receive it. Now, don't worry, you definitely do not need to memorize all 65,000 of them. But there are a few standard keys you literally use every single day without even knowing it. For example, when you browse an unsecure website, HTTP uses port 80, whereas secure web browsing with HTTPS uses port 443. DNS, which is what turns domain names into IP addresses, lives over at port 53. File transfers use port 20, and sending an email goes straight through port 25. These ports act as the exact keys to finding the right door for your data. Okay, now that we have the mechanics down, let's anchor all of these technical details right into your actual daily life. Section 5. Real-world applications. So when does TCP absolutely rule? Well, think about scenarios where losing data is just completely unacceptable. Loading a web page like Google, sending an important email through Gmail, or executing a bank transaction. I mean, if even a single byte of data is lost during a financial transfer, the whole transaction is ruined, right? Nobody wants that. Therefore, these applications rely heavily on TCP's reliable, error-checked, three-way handshake method. But where does UDP rule the roost? Think about real-time interactions, playing fast-paced online multiplayer games, making a voice-over IP phone call, or watching a live YouTube stream. In a super fast game, if a single frame of data drops, you definitely don't want the network to pause the entire game for everyone just to go back and fetch it. You just want the newest data right now. Speed is way more important than one dropped frame, so these applications choose the speedy paperboy, UDP. So the crucial point is this head-to-head comparison right here. TCP offers a solid connection, high reliability, data sequencing, and it's heavily used for web and mail. But the trade-off? It's noticeably slower. UDP, on the flip side, offers absolutely no connection, low reliability, and zero sequencing, which actually makes it perfect for gaming and video, all because it delivers those blazing fast speeds. It is all about finding that perfect balance between performance and reliability. This transport layer truly is the invisible architecture of our modern world. When you simply click a link to load a web page, you're initiating millions of invisible handshakes, segmenting data, finding port numbers, and checking for errors. And it's all happening in a fraction of a second. It is literally the absolute foundation of all internet services. It totally changes how you look at the internet, doesn't it? So I'll leave you with this final thought. Next time you experience a sudden jump or some frustrating lag in your favorite online game, will you immediately blame your internet provider's speed? Or will you picture that UDP paperboy carelessly throwing your datagram into the bushes as he speeds by? Thank you so much for watching this explainer, and keep exploring the incredible systems running quietly behind your screen.